Reactions of alkynes. Nomenclature of alkynes. An alkyne is a hydrocarbon that contains a carbon-carbon triple bond. The general formula for alkyne is CnH2n-2 for acyclic alkyne, and for cyclic alkyne it is CnH2n-4 because of the presence of ring. Alkynes can be classified under two different heads: terminal alkyne and internal alkyne. In terminal alkyne, the triple bond is present on the terminal carbon, whereas in internal alkyne, it is present in between. Let's find the names of some common alkynes. For the nomenclature of alkynes, we are going to pretty much adopt all we have talked about the nomenclature of alkanes, but the parent name is now going to end with "-ine". We are still going to find the longest carbon-carbon chain and also make sure that the triple bond is included in the longest carbon-carbon chain. Let's go ahead and find the IUPAC name for this compound. Since it has got two carbons here and a triple bond, this is going to be ethane. Since two carbon compound needs to start with the prefix eth. And since this is an alkyne which has a triple bond, it has to end with "-ine". For the next example, we are going to again count the number of carbons, but this time we need to make sure that the triple bond gets the lowest possible number. So which means we have to go from this direction. So the triple bond is present on carbon 1, and therefore this is going to be butane since it has got a total of 4 carbons. If we are going to simply put butane, it can represent 1 butane and also 2 butane, where the triple bond is present between the carbon 2 and carbon 3. So this compound should be specifically called as 1-butane because the triple bond is present on the first carbon. Let's go on to the next example. For this, we have a total of 5 carbons, and the triple bond is present on the second carbon if we count from left to right, making sure that the triple bond gets the lowest possible number. 2-pentyne. And for the final example, we are going to find the longest carbon-carbon chain, making sure that the triple bond gets the lowest possible number. So for which we are going to go in this direction. So it has got total of 6 carbons, and therefore this is going to be hexyne. But where this triple bond is present, it is present on the second carbon, so this is going to be 2-hexyne. And leaving 2-hexyne, which is this part of the molecule, we also have a methyl group, and the methyl group is present on the 4th carbon, so it's going to be 4-methyl 2-hexyne. Common names. For the common names, we are going to use the word acetylene for the carbon-carbon triple bond. So here are our carbon-carbon triple bonds, and leaving the carbon-carbon triple bonds, we are going to find the 2 substituents that is attached to the carbons which has the triple bond. We are going to put the names of these substituents in front of acetylene. So for this molecule, we do not have any substituents, so we are going to simply call this as acetylene. So for this molecule right here, we have a substituent, we have an ethyl substituent on this carbon, and we do not have any substituent here, so therefore this should be simply called as ethyl acetylene. For this molecule here, this is our acetylene part of the molecule, and then we have an ethyl group and we have a methyl group, so this should be called as ethyl methyl acetylene, more like how we name ethers. And for the next compound, we can see that there is a methyl group on one side of the carbon-carbon triple bond, and on the other side we have a secondary butyl group, because this carbon right here is a secondary carbon. So therefore the name for this molecule is secondary butyl methyl acetylene. When you have an alkyne where the triple bond gets the lowest possible number on both the directions, then you need to make sure that the substituents will also get the lowest possible number. Let's take a look into this alkyne. So on this alkyne, whether you go from left to right or from right to left, that puts the triple bond at position 4. Now if you go from left to right, that also puts the substituents with the lowest possible number, so therefore you have to go from left to right. So since this alkyne has a total of 8 carbons in the longest chain, this is going to be octyne. And leaving that octyne, we have chloro substituent and bromo substituent, which is at one at position 2 and other one at position 3, and also you have a triple bond at position 4. So this has to be 4-octane, and the substituents are going to be stated as 3-bromo, 2-chloro. For this example again, whether you go from left to right or from right to left, it puts the triple bond at position 3, right? But going from right to left is the best way because you can see that also puts the substituent with the lowest possible number. Here the substituent is at position 1, but here the substituent is at position 2. Therefore, you have to go from right to left. So this has got a total of 6 carbons in the longest chain, which includes the triple bond, and therefore this is going to be hexyne. And the triple bond is present on the third carbon, therefore it should be 3-hexyne. And leaving the 3-hexyne, we also have a bromo substituent on carbon number 1 and a methyl substituent on carbon number 5. So it should be 1-bromo, 5-methyl, 3-hexyne. Make sure to arrange them in alphabetical order. When you have two same functional groups, then you're going to use the prefixes di. Say for example, here in this case, we have 2 double bonds and therefore this should be named as diene. When considering the IUPAC name, this has got total of 3 carbons and therefore this should be propadiene. And similarly, this compound right here should also be called as diene because you have 2 double bonds and you have to make sure that you get the lowest possible numbers for one of the double bonds to begin with. Okay, so you have to go number in this direction because if you number from left to right, that puts the double bond at position 2. When you can give the double bond with the lowest possible number, then that would be the best way to name the compounds. Okay, so this is going to be hexadiene, and the 2 double bonds are present, one at position 1 and the other one at position 4, and therefore it should be called as 1,4-hexadiene, and leaving that 1,4-hexadiene, we also have a methyl group at position 2. So it should be 2-methyl 1,4-hexadiene. This molecule right here has got 2 triple bonds and therefore it should be named as diene. So for the numbering, which direction are we going to go in? Are we going to go from left to right or from right to left? If we go from right to left, that puts the triple bond at position number 1. Obviously, we have to adopt this direction. So we have got a total of 7 carbons in the longest chain, which has got the triple bond. So therefore, this should be 1,4 heptadiene. And leaving that heptadiene, we also have a methyl group, which is at position 6. Therefore, this should be 6-methyl 1,4 heptadiene. So the common name for this molecule is allene. This is something that you have to memorize. And we do not have any common names for these molecules at the moment. When you have a double bond and a triple bond present in exactly the same compound, then you have to choose the numbering direction in such a way that either one of those, the double bond or the triple bond, gets the lowest possible number. So let's take a look in this molecule. So this is a molecule where you can see that there is a double bond and as well as a triple bond present. If we go from left to right, that puts the double bond at position 2. But if you go from right to left, that puts the triple bond at position 1, and therefore you have to adopt this direction where the triple bond gets to be at position 1. So this compound has a total of 7 carbons in its longest chain, or that's the only chain present, and therefore this is going to be heptane, right? Because it has got both double bond and as well as triple bond. Now we also need to make sure that we give the positions for this triple bond and the double bond in our name. So the triple bond is present at position 1, whereas the double bond is positioned at 5. So therefore, on the whole, this molecule should be named as 5-heptane 1-ine. Let's go on to the next example here. This again has got a double bond and a triple bond. So if you go from left to right, that puts the double bond at position 1. But if you go from right to left, that puts the triple bond at position 2. So obviously you have to go from left to right to name this compound. So let's complete the numbering. Since this molecule has got a total of 7 carbons, it's going to be called as heptane ine because of the presence of a double bond and a triple bond. And then the double bond is present on position 1, so therefore it should be 1 heptane. And the triple bond is present at position 5, and therefore on the whole this is going to be 1 heptane 5 ine. Going on to the next example, we can see that there is a double bond and also a triple bond, right? We need to make sure that we include both of these, the double bond and as well as the triple bond in the longest chain. So we cannot go in this direction because that only puts the double bond in the longest chain. We cannot go in this direction because that only puts the triple bond in the longest chain. We have to go in this direction. That way we can have both the double bond and as well as the triple bond included in the longest chain. So which direction are we going to go in? If you go from left to right, that puts the double bond at position 1. But if you go from right to left, that puts the triple bond at position 2. So since the double bond gets to be at position 1, we have to go in this direction to name the compound. So it has got a total of 6 carbons, and therefore this should be hexane ine, since it has got both double bond and as well as triple bond. Now the double bond is at position 1, therefore you have to put a 1 in the front for hexane, and then the triple bond is at position 4, therefore it should be 4 ine. And leaving this part of the molecule, we have a butyl group that is existing at position 3. On the whole, this is going to be 3-butyl 1-hexane 4-ine. When the double bond and triple bond are tied, where they get exactly the same number, then the double bond gets the priority, which means it has to be given the lowest possible number. So this can be seen from this chart here, priority chart here, where you can see that the alkene is going to have higher priority than alkyne. For this molecule right here, if you go from left to right, that puts the double bond at the second position. And if you go from right to left, that puts the triple bond at position 2. So since the double bond gets the priority, it needs to get the lowest possible number. So you have to go in this direction to name this compound. There are totally 6 carbons in the chain, and therefore this should be called as hexane ine, since it has got both double and as well as triple bond. And the double bond is present at position 2, and the triple bond is present at position 4. Let's go on to the next example. If you go from left to right, that puts the triple bond at position 1. But if you go from right to left, that puts the double bond at position 1. So between this triple bond and the double bond, which one is going to get higher priority? The double bond is going to get higher priority, and therefore it is going to have the lowest possible number. So you have to go in this direction to number this chain. So therefore this is going to be hexane ine, since it has got a double bond and a triple bond, and the double bond is positioned at 1, whereas the triple bond is at position 5. It's starting at position 5. So this would be the name of this compound. Here is the priorities of different functional groups. The carbonyl group is going to have the highest priority. And the carbon-carbon double bond and the carbon-carbon triple bond is going to have pretty much the same priority. But then like when the double bond and the triple bond is tied, then you have to give preference for the double bond, which means the carbon-carbon triple bond is the one that's going to have lowest priority. Let's do some examples where we have OH and NH2 functional groups. When you have a compound where you have either a double bond or a triple bond with an OH functional group or NH2 functional groups, obviously these are the ones that's going to have higher priority, which means you have to give lowest possible number for the substituents for these functional groups. Okay, so let's take a look into these molecules right here. You have a double bond and you also have an hydroxy group. Between these two, which one is going to have higher priority? Obviously the OH, because this can be seen from the chart here. So you have an alcohol right here and you have the alkene here. So alcohol is going to have higher priority and therefore needs to get the lowest possible number. So let's go ahead and name this molecule, making sure that we get the lowest possible number for the hydroxy substituent. So it has to go from right to left for this molecule. This carbon that where the hydroxy group is attached should be 1, and there should be 2, and there should be 3. Since the hydroxy group is present on position 1, this is going to be 1 all, right? And since it has got totally 3 carbons, this should be, and a double bond present, it should be propene, which you're going to write as propen, right? And the position of the double bond is at 2. So this is going to be 2 propen, 1 all. But let's say you have a triple bond here. Let's imagine if there is going to be a triple bond here, then it's going to be 2 propyne, 1 all for this molecule if triple bond present. Let's go on to the next example. Here again, we need to make sure that this carbon by default is going to be at 1. Okay, and you need to make sure that you go find the longest chain. So longest chain is going to be here, or it can also be here. It doesn't really matter. So since it has got total of 5 carbons and a double bond and a hydroxy group, it should be called as pentanol. And by default, this hydroxy group at position 1 here in this molecule, and there is a double bond that is at position 3, and therefore this should be 3 pentan, 1 all. And then leaving that double bond or leaving this entire molecule, we also have a methyl group that is attached to position 4. So you're going to put the 4 methyl group in the front. Okay, again, if you have a triple bond here, the only change that you will make here is you will be converting this pentan into pentyne. Okay, you will be converting this E into Y. Okay, let's go on to the next example. So here you have an amine functional group. So we need to make sure that this carbon right here needs to get the lowest possible number, right? So for which we are going to go in this direction. Although we have the double bond starting at position 1, since you have an amine group which is going to have higher priority, you have to make sure that you go in this direction, making sure that the amine gets the lowest possible number. So this is going to be 1, 2, 3, 4, 5, 6, 7. So since it has got both the double bond and as well as an amine, it should be heptane amine. Now where is the position of the amine? It is at 2. So it's going to be 2 amine. And where is the position of the double bond? It's at position 6. Therefore this is going to be 6 heptane 2 amine. Let's go on to some more example. Here again we have an hydroxy group and as well as a double bond. Right? The double bond needs to get the lowest possible number. So you have to go in this direction. So this is 1, 2, 3, 4, 5, 6. Totally 6 carbon where you have a double bond and as well as an hydroxy group. Therefore it should be hexane all. And the hydroxy group now here is positioned at 2. And the double bond is at position 3. So this is going to be 3 hexane 2 all. On this next molecule, we have the hydroxy group attached directly onto the ring. By default, this position right here, this carbon right here should be 1. And you're not supposed to represent this 1 in the name of the molecule. So since this ring structure has got a total of 6 carbons and as well as a double bond, this should be called a cyclohexenol. That should be the parent name for this molecule, and you're not supposed to put the 1 here. Although it is at position 1, although this hydroxy group is position 1, you cannot put that 1 here because by default it is understood that this carbon is at position 1. Now after you assign number 1 here, which direction are we going to go in? Are we going to go in this anticlockwise direction, or are we going to go in the clockwise direction to number the ring? Okay, so between the alkyl group and the double bond is going to get priority, which means that needs to get the lowest possible number. So we have to go in this direction to number the carbons in the ring. Okay, so because the double bond is at position 2, it's going to be 2-cyclohexenol, and a methyl group is present on the 6th carbon. So this is going to be 6-methyl 2-cyclohexenol. Let's find the name for this last molecule. This last molecule has an amine group that is directly attached to the ring structure, right? So by default, here again, this carbon that is directly attached, where the amine group is directly attached, is going to be 1. And since this is a cyclohexene molecule, this is going to be cyclohexenamine. That would be the parent name for this molecule. Now, after we have assigned this to be number 1, we need to reach the other substituents in the ring with the lowest possible number. Now, we only have a double bond here. Okay. We need to reach a double bond with the shortest distance. Which direction are we going to go for that? So if we go from here to here, that puts the double bond at position 3. But if we go from here to here, that puts the double bond at position 4. So since going in this direction gives the lowest possible number for the double bond, we have to go in this direction to name this compound. So you will be putting a 3 in front of it, designating that the double bond is at position 3. So 3-cyclohexenamine is the right name for this molecule.